Calculate the mass of KMnO4 in acid medium. This is very important for us. Required to prepare 500 cc of 0.2 normal solution. What volume of this solution is required to oxidize 100 cc of 0.2 molar oxalic acid in acid medium? So we have two things here. One is KMnO4. First, we need to find what mass of KMnO4 is required to prepare 500 cc of 0.2 normal solution. Second, what volume of this solution is required to oxidize 100 cc of 0.2 molar oxalic acid. So first we'll take a solution which is KMnO4 solution, whose volume V1 is equals to 500 cc, which is equals to 0.5 liters, and whose normality is equals to, normality of the KMnO4 solution is given as 0.2 normal. We have this. Now we need to find what is the number of equivalents of this, because from that particular one we get the mass of the substance. What is number of equivalents is equals to normality into volume. But number of equivalents can also be written as weight by equivalent weight is equals to normality into volume. So now first we need to know KMnO4 in acid medium. In acid medium, MnO4 minus changes to Mn2 plus. So it changes from +7 oxidation state to +2 oxidation state. Valency factor of this is equals to 5. So the valency factor is 5. So equivalent mass is equals to molecular weight by 5, which is 158 by 5, 31.6. So this is going to be my first point. Now coming back to this, weight by 31.6 is equals to normality is 0.2 and volume is 0.5. So W is equals to 31.6 into 0.1, which is equals to 3.16 grams. So your first question is completed. This is your first part of the solution. 3.16 grams of KMnO4 is required to prepare 500 cc of 0.2 normal solution. So the first part of the solution is done. Now the second part, oxalic acid. Let us talk about oxalic acid. Oxalic acid is H2C2O4 in presence of an oxidizing agent, in presence of KMnO4, it will convert into CO2. So the carbon here is in +3 oxidation state, changes to +4 oxidation state. So valency factor is equals to change in the oxidation state, that is 4 minus 3, multiplied by atomicity of the atom undergoing the change in oxidation state, 2. So this is equals to 2 is the valency factor. 4 minus 3 is 1. 1 multiplied with 2, 2. This is valency factor of oxalic acid. Knowing the valency factor of oxalic acid, the data which is also known to us is N2 is equals to molarity into valency factor, where molarity M2 is given as 0.2 molar. So normality of oxalic acid is 0.2 into 2, which is equals to 0.4 normal, and the volume V2 is equals to 100 cc. We have N1 is equals to 0.2 normal. We need to find what is V1 is equals to neutralize this particular solution. So let us go with the second data. The second data is N1 V1 is equals to N2 V2 for complete reaction to take place. 0.2 into V1 is equals to 0.4 into 100. This is 2 times. So V1 is equals to 200 ml. So the volume of KMnO4 required is 200 ml. is required to completely react with oxalic acid, which is of 100 cc. So the answers for this particular one, 3.16 and 200 ml. Option B is the correct answer.